I'm Anil Kumar, sharing with you some very important concepts about factors. Now, this video could be appreciated by students even in junior school, middle school, and high school. And even those who are seeking jobs and want to appear in some competitive multiple choice test papers, they may find a question from this particular video. I have dedicated this video to my partner Divyansh, who is in New Zealand and is at present a middle school student and is able to solve many questions of high school students. So we are trying to see what are the concepts which can be extended so that the students in our junior middle school can appreciate and can also see how these concepts can be applied later. Factors of numbers is one of these concepts. So we'll begin with factors of numbers. So that's the first topic we'll talk about, and then move on to prime numbers, and then understand the process of prime factorization. Now these three topics are very well understood in middle school, right? So even in junior schools, they understand what factors are, and then M for middle school. Then we'll have some related questions. Some of these questions can be seen in competitive exams. So we'll also work on a related number of factors to prime numbers, and this is a place where we are going to move to high school. The questions here are: find total number of factors for the number 504. Well, I'll take an easier example here. We'll find total number of factors for, let us say, 24. So we'll say number of factors. For 24. So we'll take that example for our junior students. And then question number 2 is find total number of even factors for a number 1440. Question 3 is the prime factorization of integer n is a times b times c, where a, b, c are distinct prime integers. How many factors does n have? Question 4. If we multiply all prime numbers less than 100, how many consecutive zeros can we get at the end of the product? So we can take this for the middle school students also. I think they can understand easily. Question 5 is the prime factorization of integer n is 2 square times 12 cube times 15 square, where, well, okay, so this is not required. Okay, so you need to answer this question. How many factors does n have, and how many of these are even factors? You can actually pause the video, answer some of these questions, and we'll begin with basic concepts. Factors of a number. So the concept is, let's say, if I multiply 2 times 3, what do I get? I get 6, right? So here we call these two numbers 2 and 3, which we multiply, as factors. Now factors are factors of a number, right, which normally is called product. So what we get is a product. Now in itself it is meaningless. Just saying factors has no meaning. We have to say factors of what? So we are saying factors of 6. Factors of 6. So 2 and 3 are factors of 6. It makes sense. We can also say product of 2 and 3 is 6. Right? So it is product of 2 and 3. So that is how we refer to these terms. So I hope this concept is absolutely clear, right? Now, what we have learned is the different ways of writing factors. So let's take the number 24, which I added there in my list. So I'm writing the number 24, and we'll try to figure out how to get factors of number 24. What we should do is, we should start with number 1, since 1 and number itself is always factor of that number. Right, so this is basic rule. So 24, 1 times 24, we'll write 24 here on one end, and we are saying 1 and 24 are factors of 24, right? That means 1 times 24 is 24, correct? So let me just connect them with a line. So I thought I'll make a rainbow, but the blue colors will actually, okay, so what I will do here is we'll just randomly choose a color. So we kind of connect it, right? Since 24 is an even number, we could do 2 times something. 2 times 12 is 24, right? So 2 times 12 is 24. So we'll connect these two. So 2 and 24, 2 and 12 are also factors of 24. Now we could do 3 times 8 as 24, right? So that means 3 and 8 are also factors of 24. So 4 times 6 can also give us 24, right? Yeah. So 4 times 6 is also 24, so we can connect them also. And then comes 5 is not, and then we repeat 6. So once we reach the other end, we know we have listed all the factors. So these are the list of factors of 24, correct? You can count. How many factors we have for 24? 1, 2, 3, 4, 5, 6, 7, 8. So in all we have 8 factors of 24. So we can literally count if the list is small, right? Problem comes when we are talking about a number which is like, let's just make it 1024. Okay. So and we have to find the number of factors, then it may be slightly difficult, right? So more factors are there when you have a bigger number. That's the whole concept. 1024 is a very interesting number. I just wrote it like this. Is 2 to the power of 10. Okay. So it's good to remember that 2 to the power of 10. And once you know that it is 2 to the power of 10, we will actually see how we can easily find number of factors for this, right? So this is very interesting. So we'll just find number of factors for 1024. Okay. Now, I hope the concept of factors is clear. We'll now move on to the next concept. Or as a practice, what you can do here is have a question. So we'll just use, this exercise also. Question 1, list factors of, let's say 36. Okay. Now, do we have more factors of 36 than 24? Let that be check. Do we have more number of factors of 36 than 24? That could be interesting. So it is not necessary that if a number is bigger, then we'll have more number of factors, right? To give you an example, if I say 121, for example, right? We know 121 is just 11 times 11, correct? So it has only 3 factors, 1, 21, and 11, right? So this number has only 3 factors. So it is not necessary that the bigger number will have more number of factors, right? So I hope this concept is well taken. Now let's move on and do the next topic. Now let's talk about prime numbers. Now what are prime numbers? Well, prime numbers are numbers which have only 2 factors. Now, which are these 2 factors? The factors are what? 1 and number itself. Is that clear? So, those are prime numbers. Well, if we have more than 2 factors, then the number is called composite number. So let's write down that also here. So the other number is composite number. have more than 2 factors? And that brings us to a very popular question. Can we have a number which is not prime or composite? That's the question. Can we have a number which is neither prime or composite number? Think about it. So this is extremely important question. And the answer is yes. Most of you must have got it, but it's tricky. Some may not get it, right? The answer is yes. And the number is 1. See, 1 has only one factor. It has only one factor. Do you get it? So 1 is like unique. It has only one factor, so it is not a prime number, nor it is a composite number. Is it okay? So that is extremely important to understand. Right? So we'll take a prime factorization. So when we take a prime factorization, do not write 1 as one of the factors. Right? So that's a note. So now you know what prime numbers are. So let me just leave this here and give you a question. So let's say question number 2, which comes up in my mind, is list all the factors. Prime numbers. List all the prime numbers less than 100. So what you notice here is we are not saying which set of numbers, right? We are not saying real numbers, integers, and all those things. Perfect. We're not really making it so complicated. Remember one thing. In this topic, we are considering set of natural numbers, right? So we are talking only about natural numbers. Is that okay? So when we say list the prime numbers or composite numbers or the factors, we are talking about set of natural numbers. Is that clear? So I'll not be repeating that. In fact, I should have mentioned right in the beginning. Okay. So it's not too late. So you need to list all the prime numbers less than 100. Okay. Now here, whenever I make this list, there are a few things which help. So let me give you a hint. Hint is, do you know how many prime numbers do we have? The answer is 25. So there are 25 prime numbers. Less than 100. So remember this, if your number is not 25 prime numbers, then it is a wrong answer. Correct? Most of the time, what mistake you do is include, do not include. Let me write, do not include. So read this part after you make your list, right? Okay, so do not include numbers like, so what we do here is that there are some numbers which we do, like 7 times 13. Do you understand? So if I do 7 times 13, what do I get? 7 times 3 is 21, and so 91. So 91 is not prime. So do you understand? So what you see here is that 91 is not a prime number. Is that clear? Right. So that is very clear. Okay, 91 is not a prime number. So commonly I've seen in the list you will have 91, and that makes things problem. Well, the last number, prime number, is the, let's say, greatest one is what? So greatest prime number is what? It is 97. Okay. So 97 is the greatest prime number. Okay. So that should help, right? Perfect. Should I give you the list also? So, okay, so the list could be, I'll write in comments. Okay, that is better. So let's move on and take up the next topic. Okay, I thought I'll just move the page a bit and provide you with the list, right? So, okay, so let me write down all the prime numbers, which are 1 is not a prime number. You remember that, right? So we'll begin with numbers like 2, 3, 5, 7, 11, 13, 17, 19. And then in 20s, we have 23, 29. So remember 7's timetable, skip those numbers. Is it okay? So, and then we have in 30s, we have 31, 37. And then in 40s, we have 41, 43. You could add and see if there are multiples of 3 or 9, ignore them, okay? 47. So 7 plus 4 is 11, not 12. So that is perfectly fine. So we have 53, 59, okay. Then in 60s, we have 61, 67. And in 70s, we have a couple of them, 71, 73, and 79. And in 80s, we have 83, 89. And in 90s, we have just one, which is 97. Correct? So these are all the prime numbers. Perfect? So the question for you here, I've already given you one question. Okay, I'll give you later. Fine, because we have the answer here, so I don't want to give you that question. Perfect. So go through this list. I hope it matches with yours. So let's take up the next topic, which is prime factorization. So we learned about prime numbers only to understand prime factorization, and then we'll address this issue, number of factors. So let's not deviate from the major topic, which is number of factors of a big number, okay? Prime factorization is writing a number as product of, so we have to write a number as product of prime numbers. So that is what prime factorization literally means, right? We'll take up an example and see what. So let me take number 36 this time. We talk about 24. So 36, prime factorization means write it as prime numbers. So 36 is an even number, so we can divide by 2. Twice 18 is 36. We can again divide by 2. Twice 9 is 18, and then we can again divide by 3, and what we get here is 3. So these three numbers. What you will notice that 36 can be written as product of all these numbers. All these means these prime numbers. So if you multiply 2 times 2 times 3 times 3, so 2 times 2 is 4, 3 times 3 is 9, 4 times 9 is 36. You get 36. So what you notice is that any number can be written as product of prime factors. Note, we are not writing 1. Is that okay? You should not. Okay. Now, the senior students can also write this product as, there are 2 2's, so we could write this as 2 square times, we'll use dot convention, 3 square. So that is kind of convenient. Multiplication confuses with x or some other variable, so we'll adopt this from now onwards, right, at times. So we'll be flexible since we are moving from now middle school to high school level. Is it okay? Let's take one more example here. So let's take a number, let's say 24 once again, right? So if I do 24, let me make a tree like this. So 24 could be written as, it's good to write with prime numbers, right? So 2 times, if it is even, 2 times 12, and then 2 times 6, and then 2 times 3. So in this case, 24 is 2 times 2 times 2 times 3, and when you multiply, you will get 24. Perfect. So you can check this result. And we could write this as 2q times 3. Correct? So that is how we actually get factors. Now it is very interesting to note that from here I would like you to do an exercise, and that is my next question for you. Let me call this as question number 3. Question number 3 is, how many factors of 24? This is what you have to figure out, right? So we will learn a rule, and from the rule we'll find the answer. The answer to this question is actually 8. Okay. So if I introduce you to another question, that is, let me write down the second question, which will answer our previous question, that is, how many factors of 36. Well, we have 2 to the power of 2. There are 2 2's and 2 3's. So combination of these will give us 36, right? So if we use our rules, we'll find this answer is 9. So we have one more factor of 36 than 24. How do we get these answers? How do we get these answers is something to be understood. So I think with these simple examples, you understand what I'm saying, right? So let's again take up 24. So let me again take up 24. So how many factors? I mean, of course we can have one factor as 1, the other one is 24, right? So these factors we are counting, correct? Last time we listed them and we counted them, correct? So then if we count like this, we actually get to a number which is 8. But if it is a bigger number, it becomes difficult, right? Now, from prime factorization, I'll not make this list, we already made it. From prime factorization, we learned that 24 could be written as 2, there are 3 2's, 1, 2, 3. So 2 to the power of 3 times, there's only 1 3, correct. Now, if there are 3 2's, then factors will be multiplication of prime numbers, correct? So how many 2's can you take? So we ask one question, how many of each factor? So for 2, we have a choice. We could take one of the 2's, 2 of the 2's, all 3 of them, or none of them. So we have 4 choices here. Similarly, for 3, we could take 1 3, or we may not take 3. So we get 2 choices, right? So we get 4 times 2 choices. Is that clear? And that gives you the answer as 8. Now, the interesting question here is, you may not take any one of them, so none of them. If I take no 2 and no 3, then, well, we included that condition here. How do we answer that? No 2 and no 3. Well, you know this number 1. We know if you don't take any 2 or if you don't take any 3, 1 is a factor. So this results into 1. And if we take all of them, right, so we could have, then we get 24. You get an idea. So when you multiply them all, you get 24. Do you get the idea, right? So at this moment, we can also find number of factors. Let's say now n is the number 1024, and I wrote this number as 2 to the power of 10. So how many factors can we have? Can you tell me? Just, we have a choice of 10. So we could choose 10 of them, or we may not choose 10 of them. So not choosing is also a choice, right? Not taking 2, giving 1 as a factor. So the answer is 11, right? So this big number, 2 to the power of 10, 1024, has 11 factors in all, one more than 10. Do you see that? So it's a very handy formula which you could practice and answer such questions very easily. So I hope that makes sense, correct? So now I would like you to list factors of some other number, just practice. List factors of 30, for example, right? List factors of 30 and count how many. That is one part, and second part is test with formula. Right, so this kind of formula, which we'll write in a different way later, right? Test with formula. Is that okay? So let this be your exercise. So we'll call this as our question number 5. Okay, so let's move on to the next topic now, which is relate number of factors to prime factors. Exactly what we did just now. You're getting my idea, right? So we'll relate number of factors to prime factors. Okay, let me take the number 30 now and then relate. So if I take number 30, then I can say 1 times 30 is 30, 2 times 15 is also 30, 3 times 10 is 30. You cannot divide this by 4, but you can divide by 5, right? So 5 times 6 is 30. So we kind of make a rainbow again, correct? So we have this link. And you can easily count all these numbers and get the result. Correct? No problem. Easy. So when the numbers are like 2-digit numbers, let us say less than 50, maybe up to 100. 2-digit numbers, it is not difficult. So the number of factors are 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 factors. Now let's do prime factorization. So it's a kind of a test run for us. So 2 times 15 is 30. We could divide now by 3. So we get 3 times 5 as 15. Okay. So we have only 3 prime factors. So for 30, we have 2 times 3 times 5. Now all these powers are 1. Do you see that? So you have a choice. How many 2's can you select? There is only 1 2. So you may take it or you don't take it. So we have 2 choices. About 3's, there's only 1 3. You have 2 choices. Either you take it or you drop it. So there are 2 choices. And for 5 also, there are 2 choices. And when you multiply all these 3 2's, what do you get? You get 8. Do you see that? So without even doing that factor tree kind of a thing, we could arrive at the result. Do you agree with me, right? So that is how it will be working. So let me take one more example, and this is kind of interesting. So I'm not taking a number, right? So I'm just saying n is my number, and I'm writing its factors. So we are writing factors of 2, that there are, let's say, there are 3 factors of 2. And for 3, there are, let's say 2. And for 5, there are, let us say, there's only 1. Okay. There is no need to write 1, but for simplicity, rather to understand better, we wrote it. Now using our formula, which is how many factors in all. So for 2's, we have a choice of taking either one of these 3 2's or none of them, so we get 4. For 3, we have one more than 2, 3 choices, and for 5, we have 2 choices, right? And when you multiply these 3 numbers, you get what? 4 times 3 is 12, times 2 is 24. So we have for this total 24 factors. Correct? So that is how we actually get the total number of factors. So now let me give you a formula here. So let me just push this a bit here and give you formula. So our formula for number of factors, let's say, is if I write a number n as equal to, so these are prime numbers, right? So let's say prime number a to the power of p times b to the power of q times c to the power of pqr times so on. In that case, the number of factors will be P plus 1 times Q plus 1 times R plus 1 and so on. So that gives you the formula which can help you to find number of factors. So I hope all the things have come together now, right? So you have understood what are prime numbers, what are factors, and how do we find the number of factors. Is it okay? So that is how we do it. Let me add a question here for you. So I don't know what question number, let's say question number 6 now. Okay, so question number 6 for you is find the number of factors of this number, which I'm writing here as 2 to the power of, let's say, 3 times 12 to the power of, let's say 2 and 15 to the power of 3. So you have to find total number of factors for this number whose prime factorization, I shouldn't say prime factorization, which could be written as product of these numbers. You're getting my idea, right? Note that 12 and 15 are not prime numbers, okay? So that's kind of trick questions. So pause the video here, do this exercise, and then we'll open up all the test questions for you. I hope you're finding it interesting and useful. You can write some comments, share my videos, and now with all the concepts absolutely clear, it is time to answer the 5 questions which we began with. So I'd like you to again attempt to answer these 5 questions right here. We'll actually solve them one by one. So take your time to answer and then look into my solutions. So let's begin with the very first one, which is find total number of factors for the number 504. So we'll actually draw the factor tree. Prime factorization is the first step. So step number 1, let's write step number 1 is prime factorization. So begin with, you could do bigger numbers also, it sometimes helps. But if you don't want to break your head, just begin with smaller numbers, right? So like 2 is always a preferred number. So 2, so half of this, right? So 2 times 5, 252. Then again say 2, right? So there's no harm in just taking these prime numbers. So 2 times 1, 2 times 2 is 4, and then 12 is 6. And then again we'll take 2, and that gives you 63. Now 63, how do you get 63s? It is 7 times 9, correct? So that makes it difficult at times. Don't think that 63 is a prime number, okay? So 63 is 7 times 9. So that's how we get 63. Now, what we are saying here is that step number 2 is to write number, let's say number is n, as product of factors. Product of, I should write prime factors, right? Do not include 1 in your list. So we could write 504 as equal to 1, 2, 3. So 2 cube, 1, 2, 3. There are 3 2's, right? So remember, I could have written 2 times 2 times 2. So these are the 3 2's. And then we have 1, 7 and 1, 9, correct? So we'll use a dot convention here for product. Does make sense. So that is the second step. And step number 3 is to get the number of factors using your formula, right? So the formula, if you remember, is a to the power of p times b to the power of q times c to the power of r, so on. Then we know that the number of products will be p plus 1 times q plus 1 times r plus 1, so on. Is that okay? So in our case, the answer should be what? So we can write number of factors is what? So in our case, the number of factors for 2 are 3, so we'll write 3 plus 1, correct? For 7, there's only 1, so we get 1 plus 1. And for 9 also, we have a choice whether we take 1 9 or we do not take 1 9. That is how we get 1 plus 1. Do not take, right? And now you will see one of these choices is not to take any one of these factors, but that will give you 1, right? Since we know 1 and 504 are also factors. So we are not taking away 1 from the product. The reason is that not taking 2, 7 or 9 results into 1 which we didn't count for. 1 is also a factor. Perfect. So that gives you the answer, which is 4 times 2, 6. 6 times 2 as 12. So we get 12 as our answer. Is that clear to you, right? So that is how you should be answering this question. Correct? So you can make up your own questions, try, figure it out, and that helps. Right. Now let's take up question number 2, which is find total number of even factors. Now this is kind of interesting. So what we do again here is we just follow the same process, 1440. So we could do 4 also, right? So because the last 2 numbers can be divided by 4. So we are writing 4 will split now this way. So 4 times 3 is 12, 24 is 6, and then 0. So 4 could be split into 2 times 2. So it becomes faster. It does make sense. So 4 times 9 is 36. So we could write this as 90. Is it okay? So again we could write 4 as 2 times 2. And 9 is 9 times 10. Is it okay? And 9 could be written as 3 times 3. So this is more efficient way of writing your factors. So we get our number 1440, which could be written as 2's. And how many 2's? Let's count. So we have 1, 2, 3, 4, and 1, 5, right? So there are 5 2's times. So now let's count the 3's. So the 3's which we have are 2 3's. And now let's count the 5's. So there is only 1 5 here. Perfect. So we get 1 5. So these are this is prime factorization, right? So the first step we did was prime factorization. Correct. So the number of factors, let's say capital N, is 5 plus 1, which is 6, times 2 plus 1, which is 3, times, let me write 1 plus 1. Okay, so that gives you 6 times 3 times 2, right? So 18 times 2, 36. So we could have 36 total combinations, right? So these are total combinations, right? The question is, that is not the answer. Okay. The question here is, how many even factors? Now, so we could do it in 2 parts, 1 total, and now let's talk about even factors. How do we get even factors? So for even factors, let me rewrite this number once again. We had 1440 as equals to 2 to the power of 5 times 3 to the power of 2 times 5 to the power of 1. Now, if I have even factor, I have to include two as a factor. So the choice of not including is not there for 2, right? So we have limited choices. So for 2, we have to include. Therefore, how many choices do we have now for including 2? Only 5, not 5 plus 1, since not including 2 will give you odd number. Perfect. But for the other numbers, we have 2 plus 1 choices. So these are the numbers. Do you get an idea? Right. So when you multiply these 3, you get 30. Correct? So the answer here is 30. Does it make sense to you? Since you have to include 2, so the choice of not including 2 is not there. So if there are 5 2's, you could have either 1 2, 2 2, 3 2, 4 2, or all 5 of them. So you got 5 choices. Not selecting 2 will result into odd factor, which is not the part of our solution. So I hope that makes sense, right? So with this, let's move on to the next question. I hope my junior middle school students are still with me. Let me know how many of you are here. Question number 3. The prime factorization of integer is n equals to a times b times c, where a, b, and c are distinct prime integers. How many factors does n have? So we are given one number n, which can be found by multiplying one a with another a. Think like 2 times 2, okay? It'd be easy for you. Times 3, okay? And times 4. So that becomes distinct prime integers. Is it okay? Make sense? So basically, now we need to find how many factors. How will you find how many factors? I hope many of you must have got, right? How many factors? So we have to look for choices, correct? So what choices you have for A's? Choices for A's, choices for B's, and choices for C. So for A, we have 2 A's. So we can take one A, we can take both of them, or none of them, right? So here we have 3 choices. That means we could take 1A, we could take 2A, or we can take no A. Do you understand? So these are the 3 choices. Similarly, for B, how many choices do we have? For B, we have 2 choices. Either you take it or you don't take it. So for B, either you take 1B or you don't take it. So 0B. So 2 choices. Do you get it? And for C, again, we have 2 choices. Either you take one of the C's available to you or you don't take it. Now look here. If you don't take A, B, or C, that means if you make this choice, then think about 1 as your factor, which is a factor, right? We're not talking about prime factors. So the answer here is 3 times 2 times 2, which is 4 times 3, 12. Do you see that? So we get 12 as our answer. Does it make sense to you? So I hope the formula works and you clearly understand this formula. Perfect. Let's move on and do question number 4. If we multiply all prime numbers less than 100, how many consecutive zeros can we get at the end of product? That is to say, if I do 2 times, 3 times, 5 times, 7 times, 11 times, 13 times, so on. Well, 89 and the last number should be 97. If we do all this, then how many, you will get a big number, right? But we're looking for n. How many zeros do you get? That is the question for you. As you can see, you only get zeros when you multiply 2 by 5. Do you see that? That gives you the number 10, right? So this is 10. So 10 times all these numbers will only result into 1 zero at the end. Do you see that? So you only get 1 zero at the end. Is that okay? So you don't get number in product as 100 or 1000. You get product as a 10. So that is what the question is. So I hope now the question is understood and its solution is also clear. The last question here is the prime factorization of integer n is, let me rewrite this. This is tricky. We have 2 2's, we have 3 12's, and we have 2 15's. How many factors does n have? That is what we need to find. And how many of these are even factors? So there are 2 parts to this. I'd like you to pause the video and answer this. Here is my solution. Let's work out total number of factors. So we're talking about the number of factors, right? Now, the trick part here is that 12 and 15 are not prime numbers. So what should I do? I should rewrite this as prime numbers, right? That's why we did prime factorization. So 12 is what? 12 is prime factorized 12, right? So it is 2 times 2, which is 4, 4 times 3, that is 12, and whole cube. Do you see this? And 15 is what? 3 times 5. So you have to prime factorize. Now you see how many 2's are there. So we have 3 of this, 3 of this. So number of 2's are 3 plus 3, 6. Or let me rewrite this. Okay, let me rewrite this. 2 times, open the bracket. 2 cube times 2 cube times 3 cube times 3 square times 5 square. Doesn't make sense to you, right? So that gives you, let me rewrite here, how many 2's now? So in exponents, you have to add the powers. 2 plus 6 is 8. So we get 8, right? So 3 plus 3, 6 plus 2, 8. As far as 3's are concerned, we have 3 plus 2, 5. And as far as 5's are concerned, we have 2. Perfect. Now we can write all our answers. Does make sense to you? So the number of factors are 8 plus 1, which is 9, times 5 plus 1, which is 6, times 2 plus 1, right? So we may need a calculator. So 9 times 6 times 3. Is it okay? So that becomes the solution for you. Is it okay? So we get 9 times 6 times 3 is 18. So some of you could do without calculator. That means 180 minus 18, right? So what I do here is that we do 18 times 10 and then take away, because it is 9, right? So take away 18 because we had one extra. Is it okay? So you could do that. That is to say, we can do 180 minus 18. So that 10 gives us 2, and 9, 7 gives us 8, right? So 182. So we could multiply direct also. So you could do 9 times 8 as 72, then we get 7 here. 9 times 1 is 9, and plus 7 is 16, right? So I'm sorry. So 7 take away 1, 162 here. Okay, so 162 is a clear answer. Now this is part A. Okay, this is part A. I'm kind of exhausted by this time. Now B. How many of these are even factors? So let's write down even factors now. To find even factors, we have this number, 2 to the power of 8 times 3 to the power of 5 times 5 square. That is the number. Now for even, we have to select 8. Not taking 2 is not a choice, right? So we do 8 times 5 plus 1 times 2 plus 1, correct? So this time we get 8 times 6 times 2 plus 1, which is 3. So we get 8 times 18. So let's multiply. 8 times 8 is 64. So we get 6 and 4. 8 times 1 is 8 plus 6. 144. Do you get it? So that is how we can get number of even factors. Remember, even factors really mean that you have to include 2. 2 is the only prime factor. So we learned here also at the end, 2 is the only prime factor. Right, so I should say prime number, right? It could be a factor of a number or not, right? You know, right? For odd numbers, 2 is not a factor. So when we are talking about even numbers, we have to include 2 as one of the factors. That's what I wanted to say here. So for an even number, we have to include at least 1, 2. So I hope you enjoyed this journey, and many of our junior students also loved the idea of factorization, prime factorization, and to figure out how many factors after all we have for a given number. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'll be great. Thanks for watching and all the best.